What's up, everybody? This is Mr. Richardson coming at you live through the power of the internet. What we're going to be talking about today is how do we find the mean value given other normal distribution curve values. If you're just getting here now, make sure you go and watch my previous video on how do we apply normally distributed data to different populations. Also, make sure you hit the like and subscribe button at the bottom of this video so that you can make sure that you get all new content posted to this channel. Let's jump right into it. To review, we've talked in the last few videos about properties of a normal distribution curve, where the data lies under the curve, and how to find different values. The types of problems that we work with today, we're not going to be given the mean, and we're not going to be given the standard deviation, and we're going to have to find them. So they're going to be giving us data points that lie above and below the mean. Let's look at what we're talking about. In this problem here, we're talking about the battery life of an iPhone, and it's normally distributed such that the battery life of 4 hours falls 1 standard deviation below the mean, and a battery life of 11 hours falls 3 standard deviations above the mean. We want to use this information to determine the average or mean battery life of an iPhone. Notice here that they didn't give us the standard deviation or the mean, but they gave us other values that lie on the normal distribution curve. So the first thing we want to do is bring up our normal distribution curve and label the data that we know. We know that 4 hours falls 1 standard deviation below, and 11 hours falls 3 standard deviations above. Here we need to find the standard deviation. To do so, we can just subtract 11 minus 4. That will let us know how much these values went up by, and 3 minus negative 1, that will tell us how many spaces on the curve that we went up by. Well, 11 minus 4 is going to be 7, 3 minus negative 1 is going to be 4, and when I divide 7 by 4, I'm going to get 1.75. What that means is that our standard deviation is 1.75 because each spot here we're going up by exactly that much. So if I add 1.75 to 4, I get 5.75, and I can continue this process to make sure that I get to 11, and sure enough I do, which means that the average battery life for an iPhone is 5.75. Let's see if you can try one of these on your own. This problem we're talking about an exam, and let's say it's our Unit 6 exam on sequences and series, and we know that a score of 46 falls 2 standard deviations above the mean, and a score of 34 falls 2 standard deviations below the mean. Determine the mean of this exam, or the average score. First thing to do is draw your blank curve and think of this as a sequence. Let's fill in the information that we know. We know a score of 46 fell 2 standard deviations above the mean, and that a score of 34 falls 2 below the mean. Now it's our job to figure out what a standard deviation is. I can do 46 minus 34, see how much the exam score has changed, and I can do 2 minus negative 2, see how many spots we went up. Well, 46 minus 34 is going to be 12 over 4, meaning the scores went up 12 points over 4 spaces, which means that the standard deviation here is 3. Now I can add 3 to 34 to get the value 1 standard deviation below, which is 37. Finally add it again to get the average score, which is what we wanted, which in this case is 40. To check our answer, I like to continue to add those standard deviations to see if I actually reach 46. When I do so, I would get 43 and then 46, so that works. Let's try another example. This example here talks about the number of photos that a student views on Instagram. See if you can answer Part A and Part B. To answer Part A, the first thing I want to do is draw my normal distribution curve and realize that the values underneath it really form an arithmetic sequence. Now I want to fill in the information I know. I know that 310 falls 2 standard deviations above the mean, and that 205 photos falls 1 standard deviation below the mean. Now I can use this information to find the standard deviation. I want to see how much these changed by over 3 spaces. So I plug in. 310 minus 205 tells me how much these values changed by, and 2 minus negative 1 tells me over 3 spaces. When I do this, I can see 35. 35 is our standard deviation. Now I can use that to find the mean. Add 35 to 205, and I know that the mean here is 240. And then I can check that that works by adding 35 twice and making sure I get back to 310. Adding it once, I get 275, and adding it again, I get to 310. Now we can go about answering part B. To answer part B, I'm going to need that information that the mean number of photos is 240 and the standard deviation is 35. I want to know how likely is it that a student views less than 100 photos a day on Instagram, rounded to the nearest percent. Well, I'm going to have to use here my normal CDF function. If I want to know how likely it is that a student views less than 150 photos, I don't know what the left value is, so I'll replace it with negative 999,999. The right value here is going to be 150. Our mean we know is 240 with a standard deviation of 35. Plugging this into my calculator, I get this, which is the decimal representation of the percentage. To make this into a percent, we have to multiply by 100, which gives us 0.506%, and now I want to round to the nearest percent. Looking at the tenth, I can decide, should I round this up or keep it the same? Because this 5 is closer to 1, I'm going to round up, and that says 1%. What this means is that a student is likely to view less than 150 photos on Instagram 1% of the time. Let's try another example. This problem reads that the number of likes Noeliz receives on a typical Instagram post is normally distributed such that 60 likes falls 3 standard deviations below the mean and 150 likes falls 3 standard deviations above the mean. Part A. Use this information to determine the average numbers of likes that Noeliz receives on a typical Instagram post. And Part B. What is the probability that Noeliz will receive over 100 likes on a typical Instagram post rounded to the nearest tenth of a percent? To answer part A, I'm going to have to draw my normal distribution curve and think of the standard deviations along the bottom as an arithmetic sequence. Now let's fill in the information we know. We know that a score of 60 falls 3 standard deviations below the mean, and a score of 150 falls 3 standard deviations above the mean. I can use this information to find a standard deviation. Simply take the two values and subtract them, and subtract their position on the sequence. When I do this, I find that a standard deviation is 15. Now I can use this information to find the other values in the sequence. 60 plus 15 is 75, 75 plus 15 is 90, and finally I can find the average here. 90 plus 15 means we have an average of 105. I want to check my answer by continually adding 15 and make sure I get to 150. I add 15, I get 120. Add it again, I get 135. 135 plus 15 is 150, so it's correct. So the average number of likes is 105. Let's answer part B. In part A, we learned that for this problem, the average numbers of likes was 105 with a standard deviation of 15. If I want to find the probability that Noeliz will receive over 100 likes, I'm going to have to use my normal CDF function. Plug in my left value. Well, we want to see over 100 likes, so my leftmost value will be 100. My right value we don't know. We don't know what is the maximum number of likes that Noeliz could receive, so we're just going to label that as 999,999. The mean here is 105 with a standard deviation of 15. Plugging this into a graphing calculator, I'll get this as a decimal. And we want to round this to the nearest tenth of a percent. So first multiply by 100 to make it a percent, and then round into the nearest tenth of a percent. I look at this 5 here and decide, should I round up or keep it the same? In this case, we're going to round up and get a final answer of 63.1%. Let's try one final problem. This problem reads that the number of texts a student receives during the day is normally distributed such that sending 226 texts would be 2 standard deviations below the mean, and sending 276 would be 3 standard deviations above the mean. Use this information to determine the average number of texts a student sends per day. Part B. Based on this information, what is the probability a student sends between 200 and 250 messages a day? Round your answer to the nearest tenth of a percent. In order to answer part A, we're going to bring up a blank normal distribution curve and think of the information at the bottom as an arithmetic sequence. Let's fill in the information we know. We know that 226 texts would be 2 standard deviations below the mean, and that 276 text messages would be 3 standard deviations above the mean. Using this information, I can figure out what a standard deviation is. Simply take the upper value of 276 and subtract the lower value to see how much they've increased, and do 3 minus -2, taking those position numbers to see how many spaces you've increased. Doing this, I see that a standard deviation is 10, and I can use that to find other values. Simply add 10 to 226 and get 236. Adding 10 again will give us the mean, which in this case is 246, and I can check that this is correct by keep adding 10 and making sure I get to 276. If I do that, I absolutely will get to 276, I'll get 256, and 266. Using this information, I can answer part B. For part B, I'm going to use my normal CDF function. Here, I know my leftmost value will be 200 text messages, and my rightmost value will be 250 text messages. We learned in the earlier part of the problem what the mean and standard deviation was. We said that the mean was 246 with a standard deviation of 10. Plugging that into a graphing calculator, I find the probability. Here I want to know the probability to the nearest tenth of a percent, so I'm going to multiply by 100 so that it's a percent. Rounding to the nearest tenth would give me 65.5%. This 4 here would indicate that we would just keep it the same and not need to round up. I hope you found this video useful, and I hope it helped you to find both the standard deviation and the mean when you were given other values in a normal distribution curve. Until next time.